Now, problems like this should be very familiar for those that have already done physics. Okay? You're not going to have to worry about converting to newtons or meters per second most of the time. Most of it's just going to be in the units given, but it's trying to tie it back into the idea of those vectors. Okay? The nice thing about the vectors, they allow you to do a lot of things shortcut without having to resort to law of sines, law of cosines all the time. One like this. A force of 500 pounds is required to pull a boat and a trailer up a ramp inclined at 12 degrees from the horizontal. Find the combined weight of the boat and trailer. Okay? The problem with this will require you to draw both the diagram of the situation as well as the force diagram of it. Okay? Anybody remember that vaguely from physics?
Yeah.
No, okay.
I love physics.
Well, those that did. Anyway, so from the horizontal, I have a 12-degree ramp. Somewhere on this ramp is a boat on a trailer.
Nice.
Okay?
Good.
There, I'll add the sail. Okay. Anyway, tiny sail. So, the 500 pounds required to pull the boat. In which direction is that 500 pounds traveling?
Down.
It's pulling.
It's pulling the boat up the ramp. So it's actually following along the ramp. Now the thing is, because it's a vector, does it have to be on the ramp?
No.
No. So what you can do for this is you draw a vertical to represent the actual weight. Okay, now the vertical line, the reason we draw that straight down is because of what force? Gravity. So the idea is I draw a line. It doesn't actually matter how long it is, because this thing isn't going to be to scale. Then, at the end of this one, parallel to the ramp, I'm going to draw something representing the amount of force being pulled. Okay? How long that line is actually going to be determined by the perpendicular force to that ramp. So if I draw a line straight perpendicular to the ramp, down to here. The nice thing is if this is a right angle, that's a right angle. You see that? If this length is 500 then, the magnitude of this is 500 pounds. Well, the nice thing is the combined weight is where? Which vector represents the combined weight? Straight down. So the idea of this is your W. So, the only last part is well, what other angle do I know? And this can be kind of a little bit counterintuitive if you haven't done a lot of these.
Is it the one between the one at the wheel?
The angle
Yeah.
below the wheel can be 12 degrees too.
Exactly. The angle below the wheel will also be 12 degrees. Because this line is parallel here to here, and this is perpendicular, this angle here will also be 12 degrees. So the nice thing, and then I can just do what?
Add them together and take 180.
Well, I want W.
I know, but then you can have a complete triangle.
Why? I don't care about a complete triangle. I just want W. You could.
I always do that.
That's why tests take you so long to take. What type of triangle is it?
All right.
Yeah, you can use sine. You can use SOHCAHTOA because you have opposite of that 12 degrees. You're looking for hypotenuse. So it's literally just SOHCAHTOA. So sine of 12 is equal to 500 over, technically it's the magnitude of that vector W. What do you get?
Wow, that was big. Well, not really.
What was your
2,400.
Same.
2,404.87.
Very loud.
Yeah,
2405, right around 2405 pounds.
I mean, it makes sense because,
Should require less force to pull it up a ramp. Plus, This is the one I drew is a lot more than 12 degrees. 12 degrees is a fairly shallow angle, right?
Wait, why'd you do that little W thing? Why couldn't you just do like the sine of 90 over x and then the sine of 12?
Because sine of 90 is 1, so you get the exact same thing. I don't bother to use the law of sines when it's a right triangle. You can, it works. It's just extra writing, and I'm lazy.
Yeah, that's what I did.
Okay. Questions on that one? Okay. And actually, this one has a typo in it. Because it does say plane, so you shouldn't actually have the north and the east there.
That's only for good.
There you go. An airplane is traveling at a speed of 724 kph at a bearing of 30 degrees. If the wind velocity is 32 kilometers per hour from the west, find the resultant speed and direction of the plane. Okay, this is one where you're going to combine multiple vectors together. You're not just doing vector representations of individual parts. You're actually combining them because those forces are amplifying each other, but they're also shifting the direction. So if I want to draw this thing, where would I start?
724, we're going like 30 degrees.
30 degrees off of what? Off of north. So the idea is if I have the plane here, overall it's traveling, I'm going to represent the 724 with the length of the line at a 30 degree angle. So this is 30 degrees. The length of this line is 724. Okay? That's real. Yeah. What other force do I have going on? The wind. How would I represent that?
Drop from the tip of the other arrow going to the left. 32.
Yeah, going straight shot left. And the idea is, it's actually just down here based on that. 32 units long, straight shot, but you can move that wherever you want. That's why you can put it at the tip of that. That's also why it's called that parallelogram rule. Because it doesn't actually matter which order I do these in. I just need to add these two vectors together. Now I'm actually going to turn them into vectors, though. I'm going to turn them into component form and add them. You can do it with other techniques, but I want to do it with that vector technique. So I want to figure out what the direction and magnitude of that combined vector is. So the easy one first. How do I write 32 kilometer per hour wind coming from the west as a vector?
You have the vector on the wrong side.
Say that again?
The top vector should be going that way. From the west.
No, it's from west.
Oh.
Yeah, it's all right. It's from the west. So, how would I write that as a vector in component form?
Wouldn't it be?
In other words, component form, remember?
32 is 0.
Yeah, exactly. 32 is the horizontal, 0 is the vertical.
Okay.
Okay? Now, for the other one, I need to do a little bit more work. For the other one, I can get the vector as a unit vector by taking what of theta? Yeah, cosine and sine. Remember this from yesterday, vaguely, right? And then I just need to multiply that because this vector is only 1 unit long, so then I need to take this times what? 724 times that magnitude of whatever that vector is. So I'm going to take 724 times cosine of what? Careful.
2. Oh, 0. Wait, what?
What are you talking about?
We're going for this line right here.
Yeah, 60.
Why is it 60, not 30?
Because you want to start at 0.
Yeah, you're starting from the x-axis and going up. What is cosine of 60? Half. Sine of 60? Okay, so using those, what's half of 724? 362, and this would just be 362 root 3. Now I have these two vectors. That's these two lines here. If I add those together, it'll give me this one. So all I'm literally going to do is change. I'm just going to add these two. So that gives me what for the x portion?
394 and 362 square root 3.
394, and the vertical's still the same. 362 square root of 3. Okay? Now, the problem is this is component form. I want the actual speed and direction. So what do I actually want about that vector? Well, I have the triangle. Yeah, the length of the hypotenuse. In other words, the magnitude of the vector, right? I want how long this line is. I'm actually not even going to bother with the triangle because all I need to do with these is plug them in the distance formula. So all I'm going to do is, if I want the magnitude of that resulting vector, I'm just going to take the square root of those two things squared and add them up underneath there. What do you end up getting for the speed of the plane? Combined speed. Anybody else get that? Yeah. Yep. 740.5, what would be the units? Kilometers per hour. Now I still need direction. How would I represent direction here?
Based on the angle, because it's so many bearings.
I don't have any parallel lines to work with for alternate interior there. Yeah, well, you still have to figure out what this angle is and then figure out this angle to do that. So for this, there's actually an easier way to do it. This represents the horizontal and the vertical movement, right? Another way to describe that is rise and run. This is the what? Slope. So if that's the slope, 362 square root of 3 over 394, what is that equal to? Tangent of the angle theta. So then all I need to do is inverse tangent. So the theta is approximately what?
Wait, is it just?
It's just the y over the x. 57.9. Anybody else get that?
Yeah.
So then what would my answer be? What's the resulting speed and direction of the plane?
What is it, 57.9?
140.5 kilometers per hour.
57.9 is what happens when you do that rise over run theta. That's this angle.
740.5 kilometers per hour at a bearing of 57.9 degrees.
Nope. At what?
32. Oh, yeah.
Yeah, 32.1 degrees. Because since it's a plane, you have to go off of north. Does that make sense?
Yeah.
So that would be your actual answer.
Are we allowed to use the add symbol?
Oh, I hope so.
Yeah, sure.
That's like a perfect
It's not bad, but questions on any of it?
Why is it 32.1 degrees?
Because the 57.9 degrees is from here to here, right? So the problem is when you do an aeronautic bearing, you have to go from north. So what you actually need to figure out is the angle from here to here, from north to that line. So if this is 57.9, you just subtract it from 90. Okay, because you need that from north going clockwise. Anything else? Okay, the rest of the time is yours.